So just to give you a little bit of an idea of what this program is sort of capable of, I'm going to draw just a little demo program. What this one is going to do is calculate Fibonacci numbers. So, you know, the sequence of 1, 1, 2, 3, 5, each one adding to the one before it. Look it up on Google if you don't know. But I like calculating Fibonacci numbers because it's a very simple concept and it's an easy thing to think about, but I feel like it really sort of demonstrates a lot of the core functions of the language. You know, you have arithmetic, logic, iteration, lists, variables, all that kind of stuff. So to start off with, we're going to need to make some variables. Now that's something we didn't do last time because we didn't need to, but if you ever want to have a sort of piece of data whose value can change, if you want to record something, say, or make some sort of counter or something, you can do that using variables. Now, so if we think about calculating Fibonacci numbers, there's sort of two main steps. We're going to have some sort of a list of numbers, or an array, and the first step is to add those two numbers add the last two numbers of that list together. And then the second step is to append that number, the sum, to the list. And then we have to repeat that operation an arbitrary number of times. So we're going to sort of work backwards, and the first thing we need to do is make a program that can repeat something an arbitrary number of times. So what we're going to do that, we're going to make a variable, and we're going to do that by going up here to variables and saying new integer. There are a bunch of different kinds of variables. These should look very familiar for anyone who's done some computer programming before, but if not, the integer is a type of number variable that just holds whole numbers. So I can't put a decimal point here, but it can hold any whole integer. So, and it's automatically set to int1, but I'm going to call this counter. And so this is going to count basically how many times we want to do our operation. I'm going to set that starting to 0. And then I'm going to make another variable called max to show what's our maximum count, how many times we're going to do this operation. So I can do it like this again, or a shorter way is just click this button here, and then just start typing the kind of number we want. So I can just I is enough for integer, and then tab, and it'll make it so, and I'll call this one max. And I'll set its value to say 20, so 20 iterations. So now what we're going to do is we're going to go to our graph, and we're going to start drawing our graph now. We have what we need. So I'm going to pull down this wire, and we've got some functions here, and you can search here, so I'm going to start typing WH. We're going to use the while function. This works just like while in most languages for people who know that. But basically what it's going to do, it takes as an input this light green color, which is a Boolean variable. Basically a Boolean is just a variable that can have only one of only two possible options. It's either true or false all the time. It only has two possible values. So it's going to take this Boolean. As long as the Boolean is true, it's going to keep repeating whatever we have attached to this node. And then when the Boolean is false, it's going to go execute, keep going on from this node. So the first thing we have to do is we have to compare these two numbers to see if we want to repeat our function. So what we're going to do, there are a lot of ways we can do this. I can right click here and choose a function, or I can drag up. What I'm going to do is drag up from this node. I'm going to drop it here. And these are all the functions that output a Boolean. And we're going to choose less than. Or actually, we should probably choose. Well, we'll go with less than for now. So then what we're going to do is if we want to compare these two, we can just drag. If I click here, I get this little draggable icon. I can drag it over, drop it here. I get another little menu. This one's smaller. It's just the things that have to do with this particular integer. So I can get that integer's value, for example. This is just going to output the value of the integer, a value of the variable. I'm going to drag it and connect it. Do the same thing here for counter. You can see when I hover over this node, it turns white. That means it's possible to connect them. So, and I can drag these all around. So So basically what this is doing is it's saying every time, so it's gonna go here, it's gonna execute while, and then every time while executes, it's gonna go up here and check, is the counter less than our maximum value? And if it is, it's going to keep repeating this function on the left here, and if not, it's going to go do whatever we put on the right. So if we were to execute it right now, if I was to run it, it would just run and run forever, because the counter is always going to be 0, and 0 is always less than 20, so this is always going to return true, so it's just going to run forever. So if we want to change that, we have to drag off of here. Actually, it's probably easier to just drag from here. We have to make the counter 1 larger each time. We have to increment it. So we could do that the same way we would set any other function using set, but integers have this special function just for times like this to save space. If I drag here, you can see the increment function. So if I just connect this, now when we run this, it's going to run 20 times and then stop. So just to give you a sense of how it works, I'm going to hit run. Actually, I'll debug. Sorry, my recording software freaked out there for a second. But so what we're going to do to run this, we're going to go up here to run. I can just press F3 to debug. I'm going to start stepping through. I'm going to dock this console down here again. Make some room. So when I press tab, it's going to go to while, just like you'd expect. And we see that's undefined, so I'm going to press tab again. It's going to go up here. Now it's going to execute this less than function, but the inputs to this are both still undefined. So it's going to go up. It's going to execute get counter, so it's getting this 0 value, putting it down here. We can check that that is 0. Then get 20 from the max. 0 is obviously less than 20, so this should output true. So when we press tab, it does output true, true. So it's going to go do, since this is true, it's going to go do this function that's on the left, and then repeat, go back up and check again. So we press tab, it should increment the counter, and then go up. So now we can check to make sure that it's working by going up, up here, and then this, it's passing now a value of 1. Because even though it says 0 here, this is just the starting value for the variable. What makes it a variable is that its value can change. So when this increment function just adds 1 to it, so it now returns 1. And next time, it'll now return 2. And we can just keep going, stepping through it like this. And each time it should be getting more and more. Or we can just press F1 to complete it. So that's not very exciting yet, because all it's doing is basically repeating nothing 20 times. But that is the first part of our function that we needed to make. I'll close that. So now the next thing we need to do is those other steps we talked about. We have to have a list first of all, then add the last two numbers of the list together and add that function to the list. So think has lists built in as a type of variable, like arrays or vectors in a lot of languages. So if we press plus here again, now to signify that I want a list of integers instead of just a single integer, I do the same thing, but I start with the open angle bracket like this, and then I press I, or int, and then tab. Now this is going to be an array. So we can call this like numbers, for example. This is going to hold our Fibonacci numbers. And then we can give it any number of starting values. So for example, I'm going to say 1, 1, because I wanted to just start with 2 1s as the initial values. But we could set anything there. So now, what we want to do is add or append to this list one number, which is the sum of the last two numbers. So kind of working backwards again, often that's the easiest way to do it in this language. We're just going to pull down from here. We see we have a number of options. I'm going to add a number to the array. So you can see, I'll connect this here. You can see add takes on one, takes one argument, which is an integer, because this is an array of integers, a list of integers, so we need an integer to add to it. So now we need to calculate that integer, and we know it's going to be the sum of two numbers, so we can get add here. And then what those two numbers are, we have to get the last two numbers from our list. So the thing about lists in Think, just the way they are in pretty much all traditional programming languages, is they start at 0. So this first one is element number 0 in the list, and this second element is element number 1. So that can be weird for anyone who's not used to that, but it's kind of the standard. So if we wanted to get the last number in the list, we would want to get, so we have this get function for the list. If we drag this down here, we can get a number, and it takes an input that's the index of the number, and it outputs the number, the element in the list. So if we wanted to get the first number in the list, get the last number in the list, what we need to do is get the length of the list here, drag this again, and get length. So this is just going to give a number that's how many units are in, how many elements are in this array, in this list. But if we just dragged it like this would actually be invalid because the length is 2, but there is no element number 2. So there's only element 0 and 1. So we have to actually subtract 1 from this. So what I'm going to do, I can just drag this away and it'll automatically clear, or I can hold Alt. I'm holding down the Alt key right now, and then I just click on a node and it clears it. So now I'll drag down. I'll get subtract, I can just type the minus sign. And I'm going to subtract 1 from that number, so just how we did in the last tutorial, I'm going to get a constant integer, 1. Now this is all looking a little messy, so I'm going to clean some things up. Just drag these around a little bit. And then for this other number, we're going to do the same thing. This time I'll just use this method to show you. I can start typing get, and I can get numbers, and then again subtract. This time I want the second to last number in the array though, so instead of subtracting 1, I'll subtract 2. That's an integer 2. And then I can just pull from this exact same node here because it's going to be the same all the time, like that. So now this is it. We've written a function that calculates Fibonacci numbers, and it saves them all to a list. So if we want to just kind of see how this works, I can go to run, debug, and just like last time, this part all works the same. You can see we're getting 20 here and 0 here. So true here, so it's going. Just scroll down. After this, it's going to go to this. And then kind of just the way you'd expect, these are both undefined, so it's going to go up. This is undefined, it's going to go up, it's going to go up. Now it's executing something. You can see the length of this array right now is 2, so that's putting out 2. 2 is coming in here. So then we go up, 1, there, 2 minus 1 is 1. The first number in the array, so get element number 1, that is 1. Output. So now this side of the addition is defined. This side is still undefined. If we go up, do all this. Now element number 0. Element number 0 is also 1. 1 plus 1 is 2. And we add to the array. Now when we press tab, goes back up to here. It's going to do this whole thing all over again. And I can just press F1 or go here and run anytime and it'll finish it. So the thing is now though, we don't really have any way to see. I mean, we can kind of see that it's working, but it's not outputting anything. We don't get to look at the number, so it's not really all that helpful. So what we can do, there are a lot of ways we can do this. Probably the easiest, the fastest one is just when we're all done. So the while is going to execute this the left node here, repeatedly execute it as long as this condition is true, but then when it's false, it's going to go to the right, and it's going to do that only once. So what we can do here, this is going to get a little messy because I didn't really plan for this when I was drawing this graph. And I'm gonna write some more tools to make it easier to drag around big blocks of functions to make all this a lot faster. But for now, what I can do is I can just go log to console, and then I can just get, before we've used get to get a number, but I can just get the whole array. And it's gonna, you can see it's gonna return this kind of blue variable. Blue is for whole arrays. And if I drag this, you can see I can connect it here, but I'm going to get this little thing. This is a symbol for typecasting. Basically, just what that means is it's acknowledging that I'm giving it an array, but then turning that array into a string, into a series of characters, and it's sort of losing all its array properties, and I'm logging it as a string. So if I press F1 now, and just run it everything, gotta bring the console back. Okay, now you can see it just posted this whole list of numbers separated by commas. So this is what our list looks like in one line. We can do this a lot of other ways too. Like if we want to, for example, if we want them to be all on different lines, we can use the, and I'm just right clicking there to delete functions. So if you want them to be all on their own separate lines, what we can do, there's this, I mean, again, there are a lot of ways we can do this. We could use while again to loop through the whole list and print each one at a time. But there's a faster way to do that. What we can do is just type 4 and get 4 element in list. So this is going to take a list. Again, we can drag that a little bit. We can get, again. We can get array. So we're getting the numbers array. It takes an array argument, and then what it does is just for each element in the array, it'll repeat something, and it'll give you access to that element. So it's basically just like an advanced for loop in, say, Java or something. So then I'm going to drag from here, go back to my log to console function. Yes, I can get this out of the way to give us a little more room. And then I'm going to drag up from this green to this kind of gray node here. The gray represents that it's an sort of unknown data type because it doesn't know what type the list is. I'm working on stuff to make typecasting safer in that way, but for now, we just kind of have to know what we're doing and tell it, yes, it really is going to be a string coming out or something that can be represented as a string. So now if I press, I'm going to get this console back down. Now if I press F1, go here and run, it's going to print out all of them, each on their own line. So like that. And I mean, there are about 100 ways we could represent all this data. If we wanted to, we could instead just each time also log this number to the console. So if I get rid of this, and we can drag this down now, it's getting all a little mashed, but see here, this is the exact thing that we're converting from an integer to a string. So now if I bring this back, hit F1, it's doing just the same thing. So that's pretty much it. That's the sort of Fibonacci number calculator. So that's sort of a basic demo of the idea behind this language, but it can do a lot more. It's certainly not limited to outputting things in sort of a console format or just doing things with numbers. Think is built around the idea of modules. So what will happen is this is sort of the core language. It's got sort of the default library, all these basic functions like while and for and all these kind of traditional things in a programming language. Equals and or and all these things. But then if you want to do any sort of special functionality, like for example, you want to make a window, a graphical user interface, you do that using modules. So there are some that they're basically just like plugins. So there's some that I'm writing, and then hopefully there will be some that the community will write also to contribute to this. So you can just a bunch of jar files that you just put in a directory before you start up Think, and then it'll give you access to a whole other list of functions when you drag down here. You can see, for example, I have the file IO module running right now, so I can use it to make a file or a directory or something like that. But there's a canvas module for sort of drawing shapes and graphs and things to a screen. Hopefully there will be a more advanced window builder tutorial, or window builder module soon, and a networking module so you can make a server or communicate with the server, do all that stuff, all using this kind of graphical language. So that's Think. That's the basic kind of introduction to Think. You can check out our website at thinkvpl.org and download the latest version there. It should work on all platforms. It's been tested on Mac, Windows, and Linux. It's just Java, so any device that has Java will work. So yeah, I hope you give this a try, and I hope we can get some people using this or at least testing it, trying to improve it. So thank you.